Hey, this is Asphyxium and welcome to the How to Make a Master System Game Using Devkit SMS tutorial series number 15. In this tutorial, we create logic for the stage source code. We take a top-down look at the game workflow. We discuss the game engine logic and where optimizations were made. We also go over the concept of a substate and how it affects the game logic. There's light at the end of the tunnel. Let's go. Okay, so we're going to start by filling up the game source first before we move on to the game engine portion. And what we're going to put in here is only one single function for the game source, and that is handle game state. So the hierarchy of this game and how it runs, essentially it all starts at the main C. That's our entry point. It's what a normal entry point is for a C program, which is usually called main. And here we don't have any parameters coming in, and there's nothing going back. So where everything runs first in this game loop that we talked about some time ago. So what it'll do is it'll pull the input, which we've went over that, and then here we call the wait for vblank from devkit SMS. So we're going to wait until it gets to vblank before we do anything else. So once vblank is hit, and we'll go over what that looks like and what that is very soon, then we're going to play audio immediately after that, and then we're going to increment our frame counter. Now the one thing that we have commented out here is this is where all the game related stuff happens outside of these other functions, outside of the play audio and the poll input. So handle game state will be in our game source file. So when we go to the game source file, we can see handle game state is here, and what happens is, since we're in that loop, after vblank it will run this routine every frame. So in the loop, every frame will run this, and what happens is, depending on the game state, which is a global variable that we had defined way back when, whatever the game state is, it will perform whatever's within that game state. So when it starts off, it's game state none, which is essentially 0 here based off our defined. So when it starts off, it'll turn off the display, it'll clear VRAM. Remember, that's something in our common source code, which clears essentially the screen. And then what we're going to do is we're going to do a bank switch to get to our palette data, so our background palette data that we created some time ago as well. So again, as you can see, the very first thing we do before we use a resource is that we bank switch to that resource, and then we're going to use it. So here we're calling load background palette, which is a function that devkit SMS provides for us, that we can give that palette resource that we created some time ago through SMS Tile Studio. So we're going to bring that in. So here's the bin is the raw data, as you remember, it's a binary file. So we're going to load the background palette, and then we're also going to load the sprite palette. That's going to use the same black color throughout all the color entries for both palettes. So both the background palette and the sprite palette will get the color black put into them. And then we're going to turn display on. So now we're going to start drawing the screen again. We're going to set our game state to our initial one, which is typically the title screen. In this case, we don't have the title screen done yet. So what we're going to do is we're going to change this over to the game state stage, which is where our game will actually run. And then by default, the game mode is player 1. So this doesn't really need to be set here, but it's set because I probably did some testing, and sometimes when I'm doing testing, I'll set up the variables at a time, but this is when I didn't have the title screen put together. So here we're just going to put in stage, and you can see all the other game states. So either on the title screen, or we're running the game through the stage, or we're in some sort of cutscene, and then each one of these has essentially the same logic. So we have a previous game state and we have the game state. So in this scenario, the previous game state is at 0. So when we set the game state to say here, which is stage 2, or the value is 2, so it goes from game state none to 2. Basically, when we come into the next loop off of the v blank, we're going to check, okay, is the previous game state the same as the current game state? If it's not, then we do our, remember I have two main functions that I typically put in a lot of our entities, and that is the setup portion, so the loading portion, and then once it's loaded, then it does the updating portion, which means it runs continuously with the loop updating whatever portion that entity is responsible for. Here it's responsible for our stage game state. So here we say, okay, we're going to be, after we hit this one, we changed it to game state stage. It's going to loop through here, and then it's going to come back in our loop. And then the next time around, since the game state is now the stage, we're going to hit the stage game state. So, and then because we never set these two equal, the previous game state will not equal the game state, and then we will actually load our resources in this, the set stage or load stage, however way you want to look at it. This method, when it's done at the very end, will make these two states equal now. So the previous game state will now equal game state stage, and then also the game state will be this game state stage. So these two will then be equal the next time around after the load, and instead of running a load, now it's going to do an update. So that's essentially how at the very top level of this game, how it works, that it's structured in that way. So again, the main source code, that's going to be our loop, and then our handle game state is really going to handle the direction of where the flow of the game. So where the game's going to go, whether it's going to go to the title screen, or if it's going to go to the game engine, or it's going to go to some sort of cutscene, we can control all that with just one function in the way that I had described it. So the game engine, again, all it is a switch. So if it's this state, then do this. If it's the title state, and then do this. If it's this, this state, that's it, whatever. And each one of these source files that we are going to create for this will all have a loading phase, and then they will also have the running phase or the update phase. So that's how this essentially works. This is how you go through one state to another, and how you can swap between states and that sort of thing. So that's how it's handled at a very top level. So now let's go into our actual stage code. So the stage code is a very generic code base that will handle every stage that the game will handle. So it's this one source code, and it handles whatever stage is being loaded into it at the time. And that's all handled based off of global variables. So whatever current stage we're on, what current game state we're on, what current lives, what current mode, whatever, all that gets processed in this one bit of source code. So the first thing we're going to do, we're going to create some static data here. Remember, constant means you can't change the data in here. It's just read only at that point. So stage 1 up, these are just some tile maps that are put together to draw to the screen when I need to. So stage 1 up is actually the text for that. So what do I mean by that? I mean, if I go in here and I go into tile maps and I come back to this title main that I kept around, I come in here, and again, I have some prefab stuff. So I'm sorry, not the title, actually it would be just any one of these stages. So if we go in stage 1 and we see this one up here, that is our typical one up, the one that won't flash. So we can go in here and say, I'll get rid of this grid, and I go select here and I select this up. You can see that if I say export tile IDs to the clipboard, it should match those ones that are currently in here, and they do. So that all it is those 3 letters that represents stage 1 up, and the same for this. So I grab it for stage, for 2 up, and then for this one up and 2 up flash, these were set to those special indexes for the palette. So that palette color, when it gets flashed, will only affect these entries here. And again, that's going back to this, and I already prefab some ones over here. Here's the ones that blink with that alternate color index. So this would be the one up that blinks, and this is the two up that blinks. So either one will blink or the other will blink, depending on if it's one player or two player. And in T mode, both of them will blink. So that's how we will use this to write to the VDP to update those scenarios. And then these are the same sort of thing. So stage player 1, player 2, team, game over, stage ready, empty. This is one I want to clear out some text, so I just make them all empty. Again, those are the tile indexes that are on for that certain tile set. So 256, we started here at that offset. That's the first tile here, so that would be a blank tile at that point. And again, you can see I prefab some other ones. Here's ready, here's the game over one, prefab the player 1 and player 2, and then team play as well. So I got that all here, and then all I did was select, copy it, pop it in here, and that's all this static data is. It's just tile map data, or tile index tile ID data, or tile data, however you want to look at it. Clear player text. So this is just using Devkit SMS, and all I'm doing is I am using the stage empty to clear out the player text, and I started at the 11th tile in from the left, and the 14th tile from the top, and then I use 10 tiles by 1. So as you can see, stage empty is 10 tiles in grand total. So we just need 10 tiles across or horizontally, and it's only 1 tile in height. And again, we can go back and reference where that is within SMS Tile Studio. So I would want to clear the player text would be around here somewhere. So let me go and make a grid of that, and we can see down here where that would be if we looked at it. So it would be, see, what did we say? It was 14 and 11. So if we look at it here, this is where it would start, 14, 11, then it would write 10 tiles here to the VDP, essentially clearing what would say player 1 or player 2, or I would say team play, or whatever it says there for team mode, which I don't remember what it was. So that's all we're doing, is we're going to clear that section. There's times when we want to do that while we're in the game engine. And then here it is exactly the same thing. We're clearing the ready text where it says ready. So here underneath here, we would take care of this from 13 and 20. As you can see in there, tile X is 13, tile Y is 20. And that's where we're going to start clearing this out. And we don't need the entirety of this. We only need 6 tiles to be wiped out instead of the 10, so we only use 6 there. Then we have some opposites of that. So there are times when we want to actually set the ready text where it says ready. So again, same position, 13 and 20, same amount, but this time we're going to use the stage ready tiles in here. There's 6 of them in there. So that's all that's doing, nothing huge. And then when the game is over, there's a set of tiles that get written for that. So there's red tiles that say game over, and we're going to put it at the same height as where it says ready, but we're going to move it over about to the left about 2 tiles, since it's a little bigger, and because game over has more characters in it, and you have 10 there, and that's what we're going to write. So 10 across, only 1 row up. So this next one is set player start. So depending on whatever the game mode is, if it's team play or if it's alternating 1 player or 2 player, we're going to set certain text on the screen up. So this stage player team, that's that one that we have up here. So that I would say ready team or team play or something like that. This would say player 1, to say player 2, and we're only going to show that when the game first starts up. So it only play the audio ready track. It only plays up once in the game. That's the very first time you're on your first stage. It will show that text only on that time when the player just starts its very first stage. So it will start for player 1, or if player 2 didn't get done with it yet, there's again that global flag that checks if we need to do this. And if it is set, and obviously I could do this on stage as well, but The thing is when I can't just do it for stage 1. I have to do it whatever stage is picked first. So there's an option portion in title menu, which you can pick whatever stage you want to start on. So when you start the game, there's a flag that checks if this is the first time you played, the first stage you played, and if it is, then it will do this, and then it will turn the flag, I forget which one is on or off, to say that we don't need to run this anymore. And then whenever the game is over and you restart the game, then it resets the flag back to where this is now, where it would be available to be used again. So that's that, and moving on, we're going to go to, as you see, I also wait for vblank. So I do something, now this isn't all that intensive, but if it was intensive where we're moving a lot of tiles, we might want to wait for vblank before we do another chunk of things. So I just set it here by default, just in case, because loading up data is pretty quick, and waiting for vblank for the next iteration isn't, it's pretty negligible for the amount of time that you wait for it. So set player flashing text. This is what I was talking about. Depending on the mode, or the player 1 or player 2, it will set one set as the flashing one, and we'll set the other one as normal. Or if it's in T mode, we're gonna put the 1 up and 2 up as both flashing. But here, as you can see, in player 1, we're using only player 1 flash, and we're making the second player text on the right not flashable. And then when it's player 2, when it's their turn, when they're the current player, we're just going to take the 1 up, and we're going to make that non-flashing, and we're going to make the second player flashing at that point, because they're the ones that are up playing at that point. So that's all this does. Again, we're just going to use a simple mem copy for that, and here we use the size of whatever the array is as part of those bytes to copy over from one portion of our in-memory map to the other. See, as you can see, the team play uses player 1 map, both of them, and here in the current player map, if it's player 1, we're swapping it based off of whatever player it is at that point. Okay, moving on. This one is set player stage, where we're going to figure out it does a bunch of setup here. So set player stage, this can be called when the players change, or there's a load. This is a general purpose function. So we see what the current player is. If it's player 1, we check if it's greater than or equal to the maximum amount of stages that we have available. If it is, then we are going to reset back to the 13th stage, in a sense that there's going to be a continuous loop, and you're never going to break out of the loop. So once you get to the maximum number of stages that are available, then it's going to loop back to 13, and then you're going to start from 13 again, and then go to 25 and loop back, and then there'll be this forever loop. So there's no ending to this game, although you could make your own if you want to. I know the Sega Master System original did have an ending. And then we're going to set the stage, whatever the current player 1 stage is. So the current players, if it's player 1, we want to get to set up the current stage as the player 1 stage. And we're doing the same thing here, but for player 2 instead. So that's all we're doing here. And again, and we're in T mode, we're using index player 1 in T mode, so this will always be for player 1 and for the T mode, whereas player 2 in the alternating mode, that's what we're using here for that value. So then here we're going to set up whatever the stage map we need to load. So we're going to go into stage maps, and we're going to figure out what the current stage is, and you can see that our stage maps are 25 of them, like we put together way back when we defined the global. So we're going to get our map that we have for the current player that we're going to, or players that we're going to load the map for. So we're going to set that map, and if we're not refreshing the stage, then we're going it's basically, if we're refreshing, we do something different versus if we are not refreshing the stage. So I'll go into detail about that later. So we're going to set up our variables. We're going to set up some local ones here. The whatever the bank is for this. So we're going to get our bank that we're going to bank switch to, and then we're going to get the binary data that we're going to use for this. So here, based off the stage map, as you remember, we have a certain amount of stages that we use, and some of the layouts are being repeated depending on what stage map we're actually going to use. So here, the first map is used here and 2, so on and so forth, and we're just setting this what the bank would be for that map, and then also getting a pointer to the actual map data that we want to load in. So once that happens, we have to figure out, first we got a bank switch, again using a stage bank. And then what we're going to do is, depending on if it's player 1 index or player 2, we're going to load that map data. So the stage binary data, we're going to load that right into either the player 1 map, or we're going to load it into the player 2 map. And we're going to load just the amount of bytes that is in that map data. It's essentially saying that we are bringing in a fresh map, so fresh data at this point. So we're going back into our map data, our stage data that has been untouched. So when we reset, we're just saying, okay, or when we're refreshing, refresh the map data to its default state before the player actually goes and eats any pellets or anything of that nature. If it's not a refresh, that means we're just loading up this is usually when we're alternating the players. All we're going to do is we're going to load in what we currently have into the VDP. Again, this SMS load tile map, this is a Devkit SMS function where we're just loading our tile map data into VDP, and this is just essentially saying we don't need a refresh one. We're going to use what we currently have, whatever progress that the player made when we go back and forth, or maybe it's just player 1, it's always this. Either way, we're just going to put in our data into the we're going to take the player 1 map and we're going to put it into the VDP. So in VRAM, this is going to go. So same thing here, where we're going to place the initial map here in this scenario, and then here we're going to eventually draw whatever's in our player 1 map onto the screen. So that's what we're doing there. And again, we're going to use 1600 based off of the, we don't need the entire tile map to fill the screen. You just need enough to fill the 32 by 24 amount of tiles that the Sega Master System shows by default. Okay, so this sets the palette that we're going to use based off of the stage that we're currently in. So every stage has a different palette, as we went over in SMS Tile Studio. The stage 1 has this one too. We went all through that. So based on the stage map, we're going to grab the bank to that palette, and we're also going to set the global for the data for the palette data. So here we're going to use this later, the stage palette bank, so the current one that's being used for the current player, current stage, and then the actual data to that palette. So that's all that does. Set stage variables. So here we set the current variables based off the player. So here we get the current stage, whatever that is. So whatever the current player is, we're going to load whatever stage that, either it's player 1 or player 2. In T mode, it's always P1. The current player count. So again, that's based off of when player 1 and when there's player 2 mode and you're alternating, those will switch up depending on who's the current player that's playing. So based on the current player, we're going to get the current pellet count that's been consumed. We're going to figure out what the current ghost mode is, because remember they have that scattered and frightened mode. and then those get switched on and off. The time interval for those gets switched and get updated. So we need to get what that current mode is, and then we want to also get the current mode for that, the ghost mode timer for that current mode. So that's all we're doing is setting those global variables at certain intervals in the game. So next one. Set stage data. So again, this is a routine, a base routine that can be either used for player 1 and player 2. This data might be needed to be updated when there's alternating. You don't want to reload everything, as we'll get to another function that does that, but this is setting the stage data for the current player. It goes a bit more in depth with the resources here. So if we want to scroll where the scroll position is currently, so that's vertical scroll position, if we want to reset it back to the very top, and there will be cases when that happens, like for instance when you're alternating but the next player, when they get shown, it's going to show at the very top of the screen. So there's times when we're going to need to do that. So we're going to reset all those values that have to do with the scrolling, and then we're going to turn display off, because now we're going to, when it says a set here, we're actually going to start loading things. So here we're going to pause the game. Again, that's going to be something that the engine will recognize, and then we're going to set our stage variables like we said here. So the current player, we're going to get the current stage, the pellet count, all that stuff. We're going to set that. And then clear scroll Y, again, we're going to set the player stage. So when that happens, we're going to refresh the data that we were talking about when it came to the actual tile map data. Everything has to do with that. So the tile map data, the current stage that we're currently on, that sort of stuff will get refreshed here. Because if we have clear scroll Y, that means that most likely we're going to have to get, here we said refresh, so whatever the refresh is, we may have to get brand new data based off of the current player. So here we reflect that again. That's another method that we just completed, setting up the flashing text, setting up whatever the current player palette is based off of, this is for the stage. So again, we're going to use this palette later when we want to flash certain things on the screen. And then here we're actually going to do some resource loading. So load a palette and say the palette index for the Energizer flashing. So basically what we're going to do is we're going to switch to that bank that we already saved back up where the stage palette bank portion was, which is where we did it up here, as you recall. So we're going to load, or we're going to switch the bank to that one for this stage, for this player, this current player, and then we're going to actually load that data using Devkit SMS to load background palette data. So we're going to load that actual data, and then we're going to get the 12th color, or the 11th in reality, color from the current bin. As you remember, we strategically set up that one of these colors, I think it was this one here, is the Energizer color, and that color we will turn black and we'll constantly blink it from black to the color that it has indexed here to make it look like it's blinking. So we're going to keep that in memory. You don't really have to. I did it here for whatever reason. I could have just done this instead of putting in a global variable, but I did put in a global variable here. So we're going to use that later. Then we're going to load our sprite palette, which is just one palette. There's only ever one palette for the stage. So our main sprites palette, it will load this palette into VDP palette or color RAM. And then we're going to actually load in our sprite tiles. So if you recall, it's these tiles here. Go to Metasprite. And it's going to be these sprites with the ghosts and everything on it. So as you can see here, the first 8 tiles are left blank. That's for the player 1 and player 2. So as you can see here, I'm going to load the tiles. It's going to ask me, all right, which tiles, what tile data do you want to be loaded? So we're going to give it that sprite tiles bin, whatever whatever wanted. No, I mean, this is the data that we're going to bring in. So we're going to go back to those tiles, sprite tiles. We're going to point to that. We're going to say here, it says the tile from. So where we're going to start putting this data or loading this data. As you recall, I just said it's 4 tiles for player 1 and 4 tiles for player 2. So we're going to skip ahead 8 tiles to place this sprite tile data. And here through the constant or define that Devkit SMS and access to banks provides us, we can use that here. So if this ever changes, it's dynamic, we'll always know what that size is without having to ever change the number by hand. So here we're going to load our actual sprite graphics, and this is pretty hefty since we're doing about almost 8,000 bytes. And what I'll do is I'll wait for the next VBlank. If you don't do this, I've found that even if you have the screen off, artifacts will actually blit across the screen if you're throwing too much at one time. So 8,000, that's pretty comfortable for the Sega Master System to do. So or all these other things that are going on here. So I'll do this load, then I'll wait for the next VBlank to load more tiles. That way I don't see that garbage come up on the screen. And it's not like it's a big deal, but I don't know, I find it kind of annoying. So it's really your preference. You don't even have to do this. You could probably do all this load at one point, especially since no audio is being called here or anything of that nature. You can just pretty much straight load, but it tends to show some sort of garbage on the screen for whatever reason, even though the screen's technically supposed to be off. So we did our sprite graphics. Now we're going to load our actual tiles that we're going to use for the actual stage. So here, remember, we have these stage tiles. So those are pretty simplistic. Those are the ones that are on the stages. So when we go here and we look at this tile set, we're talking about these graphics. So the 2,168 bytes of the actual background tiles that we're going to bring into here. So we're going to grab this data. And if you recall, here we're again bank switch. I can't stress this enough. Bank switch. Don't forget the bank switch, because you're going to get some goofy results if you forget it. So always remember the bank switch. Bank switch before you use the resource. And as you can see, I bank switch every single time. This call is very important. I can't stress that enough. Okay, so we're going to bank switch to where our stage tiles are. So and then we're going to grab that data. And then again, remember how I said we're going to offset it to 256 in the second half of RAM. So that's what we're saying here. We're going to place all these graphics on the 256th tile within VRAM, and then this is the size or the amount of bytes that we're going to be over. And as you can see, it's 3,168 bytes, which is also the size of our tile set here, 3,168 bytes. So that's what we're going to bring over. Then we're going to wait for VBank again. Even though this is only 3,000, I still do that anyway. So again, probably it's something that doesn't need to be done, but whatever, I do it. And then I update the HUD, so that call to the set HUD, and then the HUD source code, I update what I need there. And to further go into that, so when it sets the HUD, it sets our bonus items at the in memory at the bottom. It sets the HUD at the top, or score, whatever it may be. And then again, we're updating the HUD bottom on the screen at this point. So these are updates to the screen, and this is the in-memory calculation. So going back to stage. So that's what it's doing there. Then we call that clear sprites. So if there were any sprites on the screen, those get cleared off. So essentially clearing out the SAT. Then we start actually setting up our entities. So remember, we have that ghost source here. Remember, I was talking about the loading portion. We're in the loading portion of it. This is what this will be called, from the loading portion. Again, from where our game H, it's this portion, that loading portion. So it's not going to have to, it doesn't need to be performant. So that's why there's so many parameters here. And maybe with some other ones, I have some parameters that are pretty high too. So here we're just going to set up all our ghosts. So each individual one, where their direction they're facing, their current state they're in, which is idle, and then the placement where they are on the map at this point. And then depending on if it's team play or if you're player 2, and default is for player 1, again, we just set up the players for them. So in team mode, Interesting enough, they're placed a little differently because they'll be side by side, not in the normal area that player 1 would be, and then their directions facing would be opposite of one another. And in 2-player mode, we set, I don't know why I have this one set. This is probably leftover garbage. So it's probably this one I needed to. It looks like I do it in the end, but that's kind of wasteful. I'm making another process here. I could probably get rid of that one. I don't know why it's there. So anyway, so we set up player 2 or we set up player 1. For the most part, I mean, really the only difference is this index here. We set up the bonus, so we reset it. We reset it to none. It's essentially not activated at this point. Again, I'm going to wait a little bit more. And then I'm going to update the bonus tiles. So those sections that I was talking about where we have to slot in the first bonus, and it has 4 meta sprites, so it was 512 bytes altogether. We just went over that in the last tutorial. So that's where we're going to figure out what the bonus is based on the stage, and then we're going to load those 512 bytes into the VRAM based off of that method that we just created. So we're going to do that for the first bonus, and so we're going to wait for vertical blank here. We're going to get our first bonus, and then I'm going to run the vertical blank again because I don't want to run these two in the same frame. Chances are they'll be the exact same thing if I did that. So then we wait until the next frame. Not really all that randomized, but this is only so, you know, when the randomization portion comes into play, it won't be the exact same thing. So that's for the most part, at least, or shouldn't be. As far as I tested it, it's not. So again, that's we wait for VBlank, do the update for slot 1, wait for VBlank, and then do slot update for the next one, second one. So then again, I wait, and then I turn on the display. Again, this is probably not necessary, but whatever. Having all these VBlanks in here, it's not going to kill anything. The player's not really going to notice the amount of time it takes to load. So this is our actual loading, base loading function that is called from the game source. So this one, that loading portion. So it turns off the display, resets the global variables, clears our VRAM. Then we wait for the vertical blank at that point because clear VRAM does take some time, and you'll notice even with the screen off, some trash will show up on the screen for the amount of clearing that we do there. And then set the sprite mode to tall because that's again a Devkit SMS provides this. So we're going to use it in tall mode, not in the normal mode. And then we're going to say use the first half of our VRAM for sprites. And I described that before, but there's 2 halves of RAM here. You have your first half, and then you have your second half. Your first half has all 256 tiles available to it. The second half, technically, you have 192 tiles available to it. And typically in a game, in a Sega Master System game, you're going to have your sprites in the first half because you're going to need that amount of tiles for your graphics for the sprites. And then usually the second half is dedicated to the background tiles or the stage tiles. So that's essentially what we're saying here. Is like, okay, we're going to use the first half for sprites because the sprite ID is not a 9-bit number. It is only a byte long. So the maximum value it can go up to is 256. That's why you have to tell it which half of RAM to go into, because it cannot go up to a number or a value of 511 or 512 total values. It can't go up to that value just using a byte. As we went over, it would need 9 bits to do a number that's relative to 512. So in the SAT, the tile index that you give the sprite, which is the graphic, that is only a byte, so it can only go up to 256. So here you're telling the Sega Master System which half the sprites are going to be on, so that ID can be used accordingly. So, and then we set the stage data again here, where setting it that it's going to refresh the data. So we're going to get a whole new batch of data or stage data. And then here we're going to start at the very top of the scroll. So we're going to clear out our scroll wide so that everything's at the very top of the map. So it scrolls down in the beginning of the game. And then here, like I said before, now that we're done loading, we loaded everything using these. Now we're going to make the previous game state equal to the game state. So now that's saying, okay, we're no longer loading anymore. We loaded everything that we needed for this stage. Now let's run the game. So that at that point in our game H here, it's now that these two equal one another. So now we're just going to do update stage. We're going to call this every loop since now this has been set. So that's what we're doing here. So that's very important. At the very end, you want to make those equal to one another so that you don't reload the game every frame instead of actually running the game every frame. So that's what that is. So let's move on. Let's go update stage palette. So again, this is where we do our flashing. So in the game engine, we'll call update stage palette only if it's within an actual game mode yet. So if it's not running, we're not interested in flashing the palettes at this point. We're only going to flash once the substate is equal to or greater than 4. And you'll see that in our setup soon. So we have an accumulator that we got from the globals. So it's a short. And the accumulator is just going to increment by 1 every frame. And then we're going to check on a certain frame if we should update the background palette. So here we're updating the 1 and 2 player one. So when we give it a 0, we're essentially saying black. So all the numbers and the colors, they're indexed by a number, by a byte value. So here, if you give it a 0, black is the first entry of that. So 0, you're saying, okay, where the 1 up, 2 up stuff is that color it's using, well, we're going to make it black now. So essentially hiding it. And we're going to do the same thing for the energizers. That was the next value, so we're going to hide that. But then when the accumulator equals 64, because we're always going to accumulate. So here we turn it off for 32 frames, and then when it gets to the 64th frame, it's going to bring those colors back on. So I know for the 1 up, 2 up, that's going to be the color white. So that's the 64th entry. Remember, we only have 64 colors available to us total from the master system. And the first color is black, and the very last color is white. So here we're saying, all right, use 60. Essentially, this is 64th entry. So remember 0 to 63. This is our last color. This is going to be white. So now we're going to turn our color for the 1 up, 2 up color back to white. So now it's displaying. And then for the energizer, it's whatever that current energizer is for when we loaded it up. As you recall, and one of the functions previously, we set the energizer color for the current player that's on the current stage. So, and then we'll get that stage color based off of that. So, and then we're going to reset the accumulator back to 0 so that when it increments another 32, again, I'll turn it off. Then when it's at 64, turn it on, then we reset it. It keeps happening over and over and over again, blinking it essentially. And the way that you would change the timing in between is through these constants. So here it's 32. For PAL, it would be different. So whenever we're in PAL mode, that would be a little different. Here's flash stage. So when a stage is cleared, we're going to start flashing the palette. So here I have to call bank switching because I'm using the bin directly. So I got a bank switch to the flashing palette, which again we created here way back when we had the flash. So this flash here. essentially makes a lot of these colors black, hiding it for a brevity, and then the borders I think still stay, they turn white no matter what, whatever those colors are. So here we're going to make it that it hides some of the screen except for the outline, and then here we're going to bring it back. It's essentially the same way that we did with this, except we're going to do this a little faster at 24 and 48. Now we're only going to wait 24 frames, and then to show it would be 48 frames. Same exact logic, except now we're just doing it for the stage. Before we call this, the accumulator will be set to 0, and it will flash about 4 times before moving on to the next stage. So here, again, we need to, since we're trying to get to a resource that's within an asset here, we got to make sure that we bank switch. So here we stored that bank previously when we load up the stage, and then here we're actually loading that palette. So essentially loading up the current stage palette at this point. I mean, we could also done it where we cherry picked the indexes, but it's a little bit more code, and this isn't going to hurt anything if I just load in the entire palette. I could have also probably limited how many bytes, but or maybe not. I don't remember. But that's all I'm doing here is loading 2 different palettes, one that turns off the stage except for the outline, making it white, and one that brings back in the stage palette to make it look like the stage is blinking. Update stage sprites. This has to do with the ghosts. Sometimes they're left in limbo when it comes to their states. So sometimes they'll be in the previous state that they were graphically. Sometimes they might have been frightened at the end of the stage, and when you look up the next stage, the way that the logic works, they'll still be in that frightened stage, even though we set the state when we load the graphics. But there's certain situations where you're loading up another map alternatively, and that doesn't get reset. So here we're going to update the ghost sprite based off of their state. Their state should be idle at this point, or whatever their state is. We're just going to make sure that graphically it fits the state that they're in. And this usually happened when, again, we went into a new stage and the ghosts will show up, but some of them were in that blue state, so they were still in that frightened state, or they were looking the wrong direction one way or the other. But this ensures that that doesn't happen. And this is the vertical scrolling. So the update stage scroll, this is looking for some conditionals. First we're going to see if it's player 1 here. So the current, whatever the current player is, we're going to see if the current player is moving. We're also going to check what direction they're facing. So if they're facing up, and then we're going to check on where they are positionally in the screen, on the screen. Well, if these conditions are met, then we're going to set the scroller as the current player, because remember, it could be 2 players, so we need to have an offset applied to the Y coordinate of the other player, depending on what player would be scrolling. It's not set up for player 2 yet, it's just player 1 for the most part, because again, when you're in team mode, the current player typically is player 1. So here I'm not checking for the type of player. That would be something that would need to be done later, so that if both of them are scrolling, that can be done asynchronously of one another, so it can give as much real estate of the screen to each player, even though they're at each end of the screen. And this is how the Sega Master System version behaved. It just hasn't been implemented here. And then what happens then, we call that common routine, which is the update the row. We're going to say what direction we're going to update. Here we're giving it just a hard-coded value. I shouldn't say hard-coded value. It would be whatever the current player's base entity speed, which would either be a 1 or 2 in most scenarios. It could be faster. It could be as variable as you want it to be. Where it starts getting a little sketchy is if you go over the value of 8, because I'm sure that would not be good, because that's more than a tile's worth. And I don't know, maybe it wouldn't be so bad. Could always try it. Something tells me it wouldn't be good. So that's all we're doing. We're doing it for when the player is moving up, and then when the player is moving down. So those 2 directions. So we're only looking at one direction to scroll, which is vertically. So let's update stage timer. So if it's paused, we're not going to update any timers because we don't want to keep counting or de-incrementing or incrementing depending on what it is. The timers while when there's nothing, when everything's being paused on the screen. So so here we're going to check if it hasn't reached the very end of the Energizer timer. Remember, this is the timer that is given to the ghost to be in that fright mode, and we're gonna when the player first eats an Energizer, this timer gets resetted to the maximum value. Here, then we're just de-incrementing it as long as we haven't reached the very end of it. Once we have reached the very end of it, or when the Energizer timer, oh, actually this is one of the first frame of the Energizer, sorry. So if it equals -1, that means we're just starting it. We're going to play that track where it plays the Energizer music at that point. Or it's restoring. I don't remember what this is. I'm talking out my butt here. Okay, I see. So once the Energizer timer, if it's greater than, we're going to de-increment. If it equals -1 at this point, that means we de-incremented past 0. We're going to restore that background music that typically plays in the stage, so that ambient sound will be playing over again. And it looks like we're still gonna de-increment the Energizer timer at that point. So this is probably a special state that I'm looking for, and then this still de-increments, so we get out of -1. So something else I probably have to look for when this. I don't remember exactly the logic for this, to be honest. But it works. So maybe it's down further in the update, and we'll take a look at that. So if the ghost timer is yeah, so this is the Energizer timer. So that's a friend's that gets counted down. But the ghost mode timer, those are the timer that intervals or goes between the scatter state of the ghost and then the chase state. So they start off as a scatter state, all the ghosts do in the beginning, and then as time goes on, they change to a chase state, and then back to a scatter state, and then back to finally a chase state. So it happens twice essentially that the state gets changed. So here, if it still hasn't reached a mode that we need to look for, we're just going to return. So then at that point, we're going to check that the ghost timer, which will be, yeah, okay. So when the ghost timer is greater than this, so this is the max value, 1680, that's 1,680 frames. So when it's greater than this amount, then we've already went through all these scatter chase things. So we don't need to do anything more with the scattering and the chasing. We're at the very end state, which is chasing, and we no longer need to increment the ghost timer or do anything special with the ghost timer. So then we're just returning. So if it's past its max value, that's all it's saying here. So we did all the scattering and the chasing. We got it all done. Now it's just in chase mode for the entirety of the stage. And then we're going to return because we already went through all the stuff. So, but if we didn't, we're going to eventually increment the ghost timer, and depending on whatever that ghost timer is, we're going to do certain things. So if the time is 450 frames, we're going to set to chasing, and then the ghost timer is going to increment some more. And then if it's at 1080, it looks like, then we're going to scattering. And then if it's at the 1680, then it's going to go to chasing. And as you can see, that value is 1680. Wherever it's being incremented, it'll then be greater than that value, and then that's why we'll return, because at that point we are already at the max value. And you can see we're using the set ghost mode call, which is a decently intensive mode call. So that would set up all the ghosts at one shot for whatever mode or state that we're putting in here, which is the chasing state and the scattering one. Like I said, when they start off, they're in scattering. So then these just swap back and forth. And then we increment the timer. So the ghost mode timer for each player gets incremented. So it's essentially this, but we have to apply it to each player because they might be in different states and their stage. Their ghost mode may have, like I said, may be in different states at that point. So we're going to increment it depending on the player, and then we're going to set our global, our current one, to that value, which is the incremented value. So it gets incremented every frame by one, except when the game is paused. So that's the logic for that. And this is the second to last function here. Here is where we're actually running the game. So the game engine this is where everything comes together and actually runs your entities and all your logic. So first thing I do, and we have to remember again, when at the very top point of this all in the main, we are handling the game state right after the V blank. So this is where you want to be when you start doing some of this logic. So again, I will play the audio, which is usually not all that intensive, and then we're just going to increment our frame counter by 1, and then this is where all our game logic gets handled. Again, it calls that source. So here we're going to actually handle our game right after the V blank, and then that's going to be called here from our game, because as you remember, we're at that point in the actual game state of the stage. So we're now updating things as we're going along. So here, this will be run every frame at this point. So the very first thing I do, I copy everything that was, all the sprites that were added to or using the add sprite function or add meta sprite function. We're gonna, all those things that we added up or put together based off of the entities and their load sprite or update sprite function. All those things should now be ready for Devkit SMS to actually put into VRAM. So that's what we're doing here. We're going to take all those sprites, definitions that we said we want on the screen, and now we're actually going to throw it over to the VDP to actually draw on screen. So that's what this is doing essentially. Sending in the VRAM so that now those sprites actually get drawn to the screen. As you can see, I use an unsafe method. This is the fastest way to do it. There is a safe method, so that means since we're doing it right after the V blank, it is safe enough for us to make this call. Because unsafe, the only time you call that and not have problems is right after V blank, or I should say right after V blank, or when the screen is turned off. So as you remember, there was a Devkit SMS routine that turned the display off. As long as this display is off, or we're right after V blank, when we're in that section where I'll show you later in Emulicious that we can do things in memory freely, because when you're in an active display, it's completely different than when you're in the V blank portion of your process. So I can get away with that. So I'm copying the sprites to the SAT or the sprite attributes table. So we're taking all those sprites that we defined and we're going to copy it right into the VDP. So now they're going to be drawn. So then right after that, after they've been drawn, I clear out the internal buffer that Devkit SMS has, or it's probably just an index that resets to 0. I don't remember exactly how it works. But now when we say initiate sprites, we're resetting or essentially clearing the entire buffer to now fill up again with our other calls, our Metasprite calls that we use. And those Metasprite calls were, for instance, again, just to go over that again, when we were in update player sprites, all our entities have this for the most part, where we call add Metasprite. So this is essentially adding to the internal buffer of, I guess, Devkit. That's the way I think it is, as a buffer for this, and you add your sprite definition to that buffer, and then so every entity has this. So this is where they add their Metasprites or their sprites, because there's other functions that other than add Metasprite that you can use. But once it adds it, then here is where it puts all that data into VRAM. And then in here, we're saying, okay, let's start all over again, because we have to draw those sprites every frame, unless you don't plan on updating them. But when you call initiate sprites, you're essentially wiping out the SAT to start over again. So that's what we're doing. So I give all the data for the sprites, and then I reset it for the next coming routines to be added into again. And then I call refresh score on VRAM. So update HUD top only updates, if you recall, when it is in view. So that's the score. When the score is in view, then it would update the score graphics. So it's always updating the score internally in that one array that we have, the score array, but it doesn't always draw, because there's no point in drawing it until it's in view. So here, if it's in view, we're going to update the graphics for the score at the top, so it refreshes as the player is going along, accumulating points. So that's what that does. I mean, the reason why I do it here is because I use this unsafe method. So I try to get all my unsafe methods done first. So if you go to that declaration, you can see I'm using unsafe SMS VRAM copy, which is extremely fast, but I have to do it when it's safe to do it. So either when the screen is off or when the V-blank, we're in V-blank mode at this, right after V-blank mode. So that's what we're going to do here. So that's why I put this at the very top of the list to be done. Stream player tiles. Again, I do that because it's using unsafe code. So again, I'm trying to push everything that's unsafe right after the V-blank, so I have enough time to update the graphics that I want without spilling into the active display. And once we get into emulations, we'll see that, and we'll go over that information and what it looks like. So again, the reason why I call player tiles right away, those are those streaming tiles. So if we go to that definition and we look at it, remember it's using unsafe. I want to make sure I put all my unsafe stuff right after V-blank. So that's what I'm doing here. I'm copying, remember, alternating between refreshing player 1 or player 2 to save some cycles. So that's why I call it there. And then update stage scroll, which if we go back to that, it's using that update row. And then we go to update row, go to that definition, you can see it's using unsafe. Again, very safe. I mean, very quick. Probably the quickest you're going to get to blita, or to put refresh a row of data visually, but it's unsafe. So make sure anything that's unsafe you do right after your V-blank. So that's again why I call this immediately. All these things here using unsafe, I call them immediately, and it should be enough. Those shouldn't be so intensive that you're going to spill over into the active display, because if you do, then you're pretty much dead in the water at that point. You'll have to either figure a way to optimize your code, or figure out, or use a safe method, because there's safe methods to everything that's unsafe for the most part in this in Devkit SMS. It'll just be ball slow at that point in comparison. And then after that, all this stuff is the unsafe stuff. So after that, it's not really as important. Update stage palette, that can be interesting. If you update the palette in active display, there will actually show little dots. I don't know if you've ever seen this. You played a game that has little dots that show up on the screen for no reason whatsoever. This could be attributed to it, because updating the palette during active display can actually show those artifacts from doing so. So I try to do this again immediately after everything. This should be more than enough time to do it. And then after that, we start updating all our entities. So we're going to update all our ghosts. Again, that's going to use those defines that we have there. So if we go to the declaration here, it's just a simple update your sprites, update your state, and then update your next frame of animation. And that's all that's calling here. So we'll run all our major game logic there. Update bonus, that's the same stuff as the ghost, but it's for the bonus. And then we're going to update the player based on, which one is currently being loaded, or if we need. So here's if it's the current player is player 1, or index player 1, and then we're going to update player 1. And then here, if it's team mode or the current player is player 2, Now we're going to update player 2. If it's the current player is in index 2, then obviously this will be ignored. But if it's in team play, we need to draw or update both player 1 and player 2 based off of whatever mode we're in. So that's what that is. And then here's that scroll lock I was talking about. If the scroll lock is not on, then we're going to reset our scroll Y amount, so that offset, that may be a pixel or two. The only reason why we have to do that, again, I explained before, is when the player chomps a pellet, the player doesn't move that frame. So normally it would add that speed because it's assuming that the player is moving there at that point when it's going up and down, but it's not, because the processing and when the drawing happen are one after the other. So we got to communicate that, okay, the player didn't move this time around, so make sure you don't add anything to the vertical amount for the other entities. That's kind of a janky way to do it. It's probably a better way to do it, but the way that I have things set up here, that seems to be the way that I've done it. So, and then ghost processing, that was that variable that I was talking about. It's a global variable that when you set it to 1, that means a ghost was already processed for this frame, so there's no reason to process another one. So like for instance, say the ghost processing is 0, that means no ghost has been processed yet. When you come into this update ghost here, it will be 0, but if it's not time for Blinky to be updated, that means it hasn't entered a new tile. Remember, the rule of thumb here is you only update when the entity moves into another tile. So it may be transitioning from one tile to the other, so it doesn't need to update yet. But if it didn't have to update, then we're going to set this to 1. So if it's set to 1, then there's logic here that none of the other ones during this loop are going to process their next target. In fact, they're going to wait. They're not going to even move at this point. It'll be like a fraction of a second here that they will stop if there's already a ghost that's been processed. So I also set this for when I set the state for all the ghosts, I set this ghost processing to 1 as well, because that already processed everything. I don't need anything else to process again in that frame. So again, saving time, a lot of time here, a lot of processing, a lot of needless processing here. So, but like say Blinky doesn't need to be updated, then I'll go to Pinky. That might not need to be updated, but then Inky does. So then it's 1 at that point, and then that's telling anything after Inky not to process until the other ones, until it has a chance to update based off of this variable. So, and it's that the speed of these ghosts are in a sense so that nothing is waiting indefinitely to update. So, and you're talking about 60 frames a second. The chances of there's no chance that these are going to all hold up one of the other ghosts from processing. So, and that's how it's done. If I had to process all these and a bonus, that probably won't be so bad for a 1-player game, and I've tested that before. I can squeeze all this in a 1-player game, but if you have a team player game, forget about it. That is not going to happen. Team player, the additional cost of the second player is pretty significant, and doing it this way was the easiest way to do the logic, because now you're only processing one ghost logic at a time, one target at a time at any given point. So I could have probably done that for the update, for the bonus as well, but I didn't. So there seemed to be quite a lot of room to play with using this technique of the ghost processing. So that's why that's there. That's how it's done. Moving on. Now, I know you're probably thinking, oh, processing 4 ghosts and the bonus doesn't seem like that would be all that intensive. Oh boy, it is. Everything you do in the Sega Master System or 8-bit world takes a significant amount of processing time, whether it's just checking conditionals or anything. You have a very, and again, we'll see this when we get into the malicious portion of it. You start seeing, you know, if I piecemeal certain parts out of it, you'll see how long things take and how much, you know, you think, you know, in today's programming languages, in today's modern programming, you know, the amount of horsepower these processors have nowadays kind of take things for granted. So this is coming back to reality in some cases. And, you know, this is, you know, the Z80 is not even a, you know, it's not a horrible processor. You know what I mean? And it can do quite a lot. So just think about, you know, things before these sort of processors or these microprocessors came out, the whole microprocessor golden age. So yeah, we'll get into that and we'll see that. So update stage, again, like I said, we have two processes here. We have the loading process, which is set stage, and then we have the updating process, which is update stage. And I control everything through substate. So I have my major game state, but then I have a substate in the major game state. And we're going to see this a lot going forward with the other things. So all the scenes are put together this way. The titles put together this way. This is no different. So there's certain things that happen in the game, so the substate controls that flow. It essentially is what it does. It controls your game flow. So, you know, these are all pretty generic, and that's why, you know, no defines were created. I just use raw numbers here, and I know that's not like it doesn't communicate each phase of a substate. I mean, I could put a define for each one of these substates, but you know, maybe that was a bit more readable, but I didn't. So when we first start off, the substate gets reset when we call set stage. The global variables portion resets our substate back to 0. So again, if I go back to set state or set stage, I should say, which is somewhere around here. Yeah, so set stage, that would be called from the game code, as you can see. So set stage will be called. So when that gets called, calls this reset global variable. So if we go to that definition, as you can see, it resets a bunch of stuff here. Substate is one of those things that resets. So it puts it at 0, and our frame counters and all that stuff gets done. The accumulators, the timers that we use that are global, anything here that I need to be reset gets reset here to paused, all that stuff. So that's what happens. So when we load, we all have that already reset down to 0. So and then when it goes to the update stage portion, as we said here, that would be after this load, then it would call this substate. It should be 0 already here. So in the case is now we're going to set our player start. So that logic we had to show the player text and play the fanfare based off of that. It gets played once if it needs to, and then what we're going to do is going to increment to the next state. So once this is done, which is very small, we're going to go to our next substate. And here all we're doing is waiting 60 frames. This is so we can show the score at the very top before it scrolls down. If I didn't do this, it would just immediately scroll down. And you want to give the player a little bit of time to see what their score is every time they start a new stage. So that's what we're doing here. We're going to wait 60 frames till that happens. And once it hits that threshold using increment timer, we're going to go to the very next substate. So now we're incrementing again. So now here, we waited at the top, looked at this, gave the player enough time to look at this, the score. Now we're actually going to scroll from the top to the bottom. And here, we're going to set our scroller for this portion of it. Again, this runs in a loop over and over again. We're going to set it to the auto scroll. So nothing else needs to, or everything will be affected by the auto scroll. That means even the players, on top of it all, they will be offset by that scroll Y amount offset. So everything looks like it moves smoothly with the stage at that point. So, and then the update row is when we're actually doing the scroll and we're saying, okay, we're moving down at that point, and we're giving it 1 pixel per frame. So we're going to move the scroll 1 pixel per frame. So that's how we're going to do it. It doesn't move fast, doesn't move slow, just moves 1 pixel at a time, nice and smooth. Then we're going to check if the players have been through the first run or not. So here, that's that flag, P1 start. Okay, if it's 1, then we're going to clear out the player text. And then here, we're going to show because we're scrolled to the bottom at some point in time. We're going to show that life being subtracted from the bottom. So we're going to take that one of the player lives at the bottom. I'm going to put it on screen. That's to show the behavior of the original game. They did it the same way. And then we're going to update once we take that life away to show on the screen that we took that life away at the bottom and put it on the screen. And then we're going to set that flag to 0. That means we've now started the game. We don't need to do any of that fanfare. We don't have to show any of this stuff anymore. We can just play the game normally. And then we're going to bounce out of the substate. So then that's for player 1, and then for player 2, the same thing whenever they go. So again, we're gonna check if the current player is this, that, if, this sort of thing, and we're gonna show that. And then if it's none of those things, we're just gonna draw here. When I say run game, this is only to show the sprites. We're not actually running the game. This is just to show the sprites. So we still need things to be streamed in tile-wise and a bunch of other things, and we need to run those update sprite routines. So it's the only time why I say run the game, but I'm actually only doing it for the purpose of showing the sprites on the screen. And then when the scroll gets to the very bottom, which is 96, as we talked about, is our max value, we're going to update the bottom HUD again, and we're going to, or not again, it's just because of this certain scenario. We're going to the next state. So update the entities is our next state. So here we're running the game to show the sprites, but they're not doing anything at this point. And then we're going to wait 90 frames. Why I wait 90 frames? That's because then the beginning BGM music, or the starting BGM music, should be done, or I have to wait for it to be done at that point, and then I wait just a little bit more till I do this. So then at that point, once all that's done, we showed the players, we showed the enemies, we went through everything, showed the text. Now we're ready to set our game entities. So now we're going to unpause the game. We're going to set all our stuff up. So we're going to set player 1 as moving. We're going to set Blinky into the first ghost mode, which starts as scatter. And then Pinky is going to be leaving the ghost house. Pinky's in the ghost house in the beginning, whereas Blinky is on top of it outside. That's why we're setting the ghost mode for Blinky. When it comes to Pinky, they're inside the ghost house, so their first state is to get out of it. But once they get out of it, then they get set to the ghost mode state. And then the other two, which is Inky and Sue, they're on the left and right. They're in the house mode, but then they're going to be, eventually when their timer is up, depending on what stage they're in, they're going to move to the left and right, respectively, and outside of the house. So that's what we're setting. They're setting their entity states to that, and then they'll be updated accordingly. So again, that's an update state sprite. So we're going to make sure before we show the sprites, based on the states, we're going to make sure that they're reset to the correct state that they're supposed to be. Then here, if it's in T mode, then we're going to also put player 2 in there. Okay, and then here we're just going to clear the ready text where it would say ready, which is in the center, and then we're going to play our background music and then move on to the next state. So now we've essentially set up the beginning of our gameplay. So before moving on, now as you can see here, we're just running the game. So we're going to run the game and we're going to update our stage timers. That's what we're doing. I actually could have probably called that within this too, I believe. I may be wrong, but I didn't have to specifically put it outside of it, but I did. So here we're essentially running the game, running our countdown timers and our other blinking timers and all that sort of thing. So this is our main game loop where we're actually running the game. And then depending on what happens later on, based off of this, down here are all the other states that could possibly happen. So the player got chomped. So they got chomped. We're going to run the game to show the sprites. And the timer is on the player code side. So when that player is chomped, you don't want anything else to run. That's why we have a different state here. When the player's chomped, it'll stop essentially, or pause everything, go through its states, which it still needs to show the sprites for that. it's going to go through its states, as in spinning around, making the music and everything. It has a timer for that. And then once that timer's done, the player is the one that sets the next state. As you can see, like substate plus plus doesn't happen in these two because this substate's now controlled from elements or entities outside of this game loop at that point. So when it's here, we still need it to show the graphics, but it doesn't fit any of the other states. This is just when the player gets chomped, so that's case 5. When the stage is cleared, we're going to wait, or we're going to set it, we're going to clear or refresh the spice based off of whatever they're at in that current time. So again, we're just going to keep on doing that. So as long as the timer is less than or equal to 1, that means while the timer is being counted down, we should still draw the sprites on the screen. And in that time, what will happen is we'll wait 60 seconds or 60 frames. Sorry, we're going to reset our accumulator because now we're about to flash the screen or to flash the stage at that point. So again, stage cleared. We're going to wait 60 frames, which is 1 second essentially. So we're going to pause just a little bit like it says here. Then we're going to go to flashing the screen. So now the accumulator is reset to 0. We're going to go to the next one, which will be flashing the screen after it's been cleared. So here we're going to call that. We're going to flash about 4 times. We're going to wait that 104 frames for that to do that. And then once it meets that threshold, now we're going to go to the next substate, which is loading the next stage. So substate 8 is load the next stage. So again, we're going to pause a little bit here for 30 frames at this point, which is very small. And then we're going to, if it's at a stage where we need to run a cutscene, this is where we would go next. So we would go to that cutscene next based on the stage. However, if the next stage is not the cutscene, then what we're going to do is set the next player's next stage, which is a function that we have outside of this, which sets the current stage and increments the player's next stage. Again, looking for that logic that it could be over 25 and then it has to reset back to the next stage or something like that. And then we have set stage. Again, that's that function we have in here that essentially resets all our stuff for the next coming stage. Here, when the player finally, when it's chomped, it may go into a state that's the 9th substate, which means that the player is dead. This is the most complicated logic. Again, we're running run game only because to refresh the sprites. Here, we're going to increment the timer overall. And actually, that could be not nested in that way. Goes against my very fiber of my being. I don't know why I wrote it there like that. But anyway, so we're going to check 60 frames. It didn't meet the threshold. If it did, then we're going to do some logic here. We're going to check if it's player 2. We're going to check if it has lives that continue. So either it's going to alternate, or if both player 1 and 2 don't have any lives left, then it's going to be a game over at that time, at that point in time. So if they both don't have any lives left for them to play, depending on how things worked out when they were alternating, then we're going to clear all the sprites off the screen, and then we're going to set our game over text, and then we're going to set it to the game over substate. So, and then if the players do have, or there's some life when we're going to alternate to the other player, then we want to take that in consideration. So we're going to switch to whatever the current player is going to be now. So the current player, if it was 1, is now 2 at this point. And then if that fanfare hasn't played for the second player, which it would really be the only one that really applies to. So player 1 got its fanfare, but now player 2 finally gets to play, and they haven't had their fanfare. Then we're going to set the stage call, make that set stage call instead of setting the data as being reset or moving on to loading the current data for whatever current player it is. So that's what we do there. And then if the current player is player 2, we're going to do the opposite. Now we're going to load player 1 at this point. Again, we don't have to worry about this because player 1 will always have its fanfare played the very first time it comes on, whereas player 2 would not, based off the logic we have. So we check for our stuff here, and we're going, this last one is that we're actually not switching the player, so we're just moving the current player along to the next stage, or whatever that, or this current stage or the next stage, whatever may be the case. We're going to start loading that data in. Here you can see that we're not refreshing the data and we're not clearing the scroll, so wherever the player was, if they're the current player and they got chomped or whatever, then it won't start at the very top of the screen. It will just be wherever the player got chomped, and then scroll it down to the bottom, and then set the ready text to play again, and then we have our substate reset to 1, which will go all the way back to the top when we basically start the game. So when we set it to substate 1, this is also giving the HUD at the bottom a chance to remove a life or show that to the player that one of their lives was taken, and that sort of thing. So it does some updates there, and then this is just a hard reset of the stage when it doesn't need to be refreshed, it just needs brand new data regardless. And then we're going to start at the very beginning, and that may be the case again for player 2. So if it's not game mode 2 player, or so here we have, again, we're looking for 2-player game. This is one that's alternating back and forth. If we don't have to worry about any of this alternating back and forth crap, then it's pretty simple at that point, because then we know that we're only dealing with player 1. And even in team mode, player 2 and player 1 shares player 1's life count. So this is a lot simpler if you only have one player instead of alternating. And alternating one, there's a bunch of conditions you have to look out for. This is pretty straightforward. Here, if it's less than 0, then we're going to set it as game over. We're going to clear sprites, set the text to game over, and then we're going to go to our game over substate handler. If it's not game over yet, then we're just going to reset our data again. We're not looking to refresh, so we're going to use whatever the current state of the player 1 map data is at this point, and also where player 1 is in the scroll. We're not going to reset it to the top, so that's why it's 0, 0. We're going to just use where the player has got chomped, and then we're going to scroll to the bottom. And that's what we're going to do here. Again, we're going to set the ready text so that shows up for the next life, that their chance that the player is going to have. And then we're going to set our substate back to 1, basically restarting the whole process over again. And then at the very end, the last substate that we really care about is the game over substate. So here we're just going to wait a little bit. That's as you notice, we're not going to draw any of the sprites because I don't make that call to running the game. So none of the sprites will be shown. We're going to wait 120 frames, so it has time to show the game over text. So I'll show the game over text for 120 frames, and then once that is done, we're going to reset all the player variables, and then we're going to bounce out to the actual title screen at that point. So essentially game over at this point. And I think that is everything that has to do with the actual game engine. What I'm going to do, I thought maybe I would be able to get the malicious part done here, but I'm not going to do that. I'm going to wait until the next tutorial, and then what we're going to actually do is really build this game, run this game, look at malicious, piecemeal some code so you can see what the differences are between each part and what it does and what to look for when you're trying to profile your game. There's profile tools also in malicious, but for the most part, I just use the visual representation of what's happening on the event viewer, and sometimes I'll use the debugger to look at some of that stuff, but I'll show you that, and we'll go from there. So hopefully you enjoy this one, and I'll see you next time.